Hello, my name is Jeremy Jessica Carroll, and my topic is Cloud Native Integration Testing. I work for Coursera. The takeaway from this talk is that integration testing best takes place between deploy and release of an individual component within a microservice architecture. After this talk, you will understand why integration testing is difficult for cloud services. You'll understand when it's important to do integration testing. You'll understand the microservice service principles that enable scalable integration testing. So microservices are independently deployable components, and these get released to production traffic after they have been deployed. And using per request routing before they have been released allows us to test pre-production deploys and then release them. The testing also requires staging databases. Also, I hope that after this talk, you'll be motivated to read the paper. And if you don't have access to the proceedings yet, you can look in the archive to find it. So we've covered the goals. We're going to do the background, then we're going to look at our contribution and conclude with the advantages and a summary. So what is an integration test? Many integration tests use the UI, in our case, the browser, and automate the user activities, a user-facing story, typically a high-value flow. And the integration test will touch multiple components and verify dynamic behavior, modifying state as it goes. So an integration testing involves the whole system. Integration testing needs to have a well-defined version. There's no point in testing something if you don't know what it is and you can't forward that test result onto a product release. You focus your integration testing on high-value flows. It's not possible to test everything. An important issue in integration testing is fidelity to non-functional features. This has been there for many, many years, but it's difficult to know exactly what the customer sees unless you have good fidelity on a whole variety of aspects of the system. You need to include rarely used flows because, so for example, in Coursera, a critical high-value flow is the one where we create a new degree. We don't create that many degrees, maybe 1 or 2 a month. So these are rarely used, but we need to test them every time we run tests. So we test the create degree flow much more frequently than we actually use it. A key aspect, a key challenge with integration testing for the cloud is scalability. But scalability is a key cloud native feature. And the scalability that we care most about is scaling the team. As more engineers join, because the component size and team size are roughly constant, this means we have more components and more teams. We also, as we have more engineers, they write more code, and the more code needs more tests. So we have scaling of components, scaling of teams, scaling of tests, and each engineer deploys once or twice a week, say, which is scaling the number of deploys. So as we increase all these things, there appear to be quadratic forces on the number of test runs we need, and possibly even cubic forces on the need for test infrastructure. But we wish the cost to remain to scale with the team size, not to have these quadratic factors. So there are different approaches to integration testing. Classically, each team would have their own test system. This means that you need n copies of the system. There's no bottleneck, but in a cloud environment, it's very difficult to guess what version you need of other components you need to be using to test against. The non-functional fidelity of such systems has always been poor, and there's nothing in the cloud that allows us to make it better. We do include high-value flows. We do include low-frequency flows. A release train is one of the possible solutions. where there's a single staging version of this whole system, which is centrally managed, and we schedule weekly releases with all the teams integrating their parts into the train as it proceeds towards integration testing. There's only one copy of the whole system, but this creates a bottleneck. The version being tested is the next version of all the components. This tends to have better non-functional fidelity than the per team testing, because somebody on the central team is responsible for making sure that it's reasonably good. This covers high valued flows and low frequency flows. With the cloud, testing in production is another approach, which is in many ways unavoidable. We can't test everything, and so some flows won't be tested until we start rolling out a deploy to production traffic. This can be in a canary facing 1% or 10% of the traffic, or a blue-green release where you shift the traffic maybe 50-50. You need no copies of the system. There's no bottleneck. The version tested is the current production version of all the components. The non-functional fidelity is excellent. This is production, so it's exactly like production. It doesn't test high value flows specifically, and it definitely doesn't test low frequency flows. And this can be used in place of any integration testing, particularly if you have no high value flows. So for Coursera in the early days, where our main product was a MOOC, where people weren't paying large amounts of money, testing in production was our primary form of testing. As we moved into the degree market, where people are paying thousands of dollars, this was no longer a satisfactory solution. So cloud native integration testing, which we are presenting, has per component testing between the deploy step and the release step. Again, we have no additional copies of the whole system. Again, this doesn't provide a bottleneck, and we use the next version of that single component under test and the production version of everything else. This gives very good non-functional fidelity. It's not quite as good as testing in production because we use staging databases to separate out the test activity from production activity. But like the earlier approaches, we can include high value flows and low frequency flows. So that's the background. Now our contribution. The key observation, which is not our contribution, but part of microservice architecture, is that deploy is not the same as release. We can deploy, the step of deploying is where we build and connect infrastructure for a specific component. The step of releasing it is when we start sending production traffic to that component. We can have multiple deploys. We can have deploys that we never intend to send production traffic to. The space of deploys is open for exploration. There is typically exactly one production version of each component, and this is essentially just a label on one of the deploys to indicate that production traffic should go here. A deploy is in many ways unverified. It could even be not from the main branch, or not even reviewed. In our paper, we talk about deploys that have come from the main branch and have already been reviewed, but they're still not verified, in the integration testing hasn't happened yet. And after verification, after integration testing, then we can release a deploy. So to see how that works in practice, here's a picture of a system with a service mesh with three services microservices within the mesh, a gateway, and some JavaScript bundles. The production components are shaded. We see that service B is in a blue-green rollout phase. So production traffic comes in on the left and goes in through the JavaScript code, either maybe a server-side rendered JavaScript code, through the gateway microservice into the service mesh, and it hits the production versions of everything, including the staging, including the production databases. That's what production traffic does. A local JavaScript developer may have their own code locally, and their traffic goes into their local system and then goes through the mesh gateway and the production versions of all the services, but hits the staging databases at the back. This separates the local development from the production traffic. When we're doing a regression test on service A, as we're contemplating rolling out to the pre-production deploy, the traffic goes through the production versions of everything except for service A, in which it goes through the pre-production deploy that's under test, and we use the staging databases again to separate out the test activity from the production activity. And we can similarly do a regression test on a JavaScript bundle, and we can use the same infrastructure for doing synthetic testing, using production components throughout, but the staging databases at the back. So the staging databases are the one item that we've not discussed in any detail. These are simply, in our case, daily copies of the production databases. And this allows us to separate out the production activity from the test activity, so that the test activity doesn't modify the state of the production system for the main users. So we go back to the summary from the very first slide. Deploy is where we build the infrastructure. The code here has been tested. It's passed unit tests. It's probably been reviewed, and it may already have passed integration tests in an earlier phase. But the main integration test phase comes after we deploy. And now we're testing the new component with the rest of production. So we know that once we release it, it will work with production as it really is right now. And the non-functional features of production are just as they are. We have true fidelity. Once the integration tests have passed, we can then release the component by shifting production traffic to it. Notice that for the integration test to work, we need to be able to annotate every request from the integration test with something like a cookie that specifies which versions we need to use, so that we can direct the traffic from the integration test into the pre-production deploy. So the advantages of this approach is that this is scalable with the org size. That we're not introducing any new hardware for running the tests. The number of tests needed for each component is not all the tests, only the ones that touch that component, which is going to be roughly constant. So there are no bottlenecks in this approach. The approach covers the low frequency flows and the high value flows. We also get read-write synthetic testing for free, and we get non-functional fidelity. The version fidelity, we also don't have the versioning problems of either the per team testing or the release train. So we've seen that integration testing for cloud services is difficult, and that integration testing is important when there are high value or low frequency flows. And we've seen that using pre-production deploys with per request routing, that this enables scalable integration testing within a microservice architecture. We also need staging databases. And please read the paper. Thank you.